We're a player in the closed loop game. Most of us are either ex-drillers or completions engineers. A few people on our team, they're fracking experts, so to speak. Us at Icarus, we fall more into the enhanced geothermal side. And really, it's the enhanced geothermal space. It's the Wild West at the moment. Nobody really has true definitions of what is what. So underneath enhanced geothermal, you see a lot of different technologies. We're jumping on the bandwagon here of saying that there is another nest inside of enhanced geothermal called advanced geothermal. Closed loop is the ability to never lose water down hole, right? Where we design a certain length of lateral to increase as much volume and surface area into that hot rock as possible. But then we strategically drill 2, 3, 4, 5, however many wells it takes, because we have a really good handle on the modeling of how fast the rock will cool and how fast it can replenish itself once we shut a well off. And we basically designed a multi-fingered coaxial setup so where we can turn a well on and shut it off, go to the next well, turn it on, shut it off. But we create this static and dynamic cycling states for our wellbores that even though our wells down hole are turning on and off at surface, we bring them all to one point. So we have a constant flow out of hot fluid. I think the future of geothermal, full integration into society, maybe that's a little bit of a pie in the sky type answer, but when you think of geothermal, it's one of the few energy sources that truly is sustainable from the standpoint that, us in the closed loop space, our waste fluid isn't waste fluid at all. It's fresh water that's exiting a binary ORC plant at 120 to 150 degrees Fahrenheit, more than adequate enough to be direct heating applications for hot water for your house, heating a commercial building, even pumping over to agriculture. So when it comes to the value stack, it can be power generation, it can be direct heating, it can supply various different industries, and then ultimately it's really small footprint. So it's a win across the board.
Welcome, everybody. I am fired up today to be moderating a panel on a topic that I believe is very key to the future success of geothermal energy industry. This panel will be pivoting oil and gas technologies to improve geothermal well design outcomes. This is a topic that is near and dear to my heart, coming from the oil and gas industry and key to the success of my business. I am Sarah Jewett. I am the Director of Strategy at Fervo Energy. My company is hard at work to increase geothermal drilling outcomes. I am very much looking forward to finding out from our lovely panelists what work they and their companies are doing on this topic as well. So without further ado, I would like for each of our panelists to introduce themselves. We're going to start with Scott. Go ahead.
Hi, thanks, Sarah. I'm Scott Farmer. I'm a principal drilling engineer at DrillScan, which is part of Payne. I've been in the oil and gas industry for 11 years now and moved over to join DrillScan last year, mainly to join in the geothermal incentives that we were working on and help out companies like Fervo and all the other ones that are based in the US and Europe. And my previous background is HPHT drilling engineering and product owner for a drilling engineering software application. So pleased to be here.
Excellent. Thank you, Scott. Brage, do you want to go next?
Thank you. Thank you, Sarah. My name is Brage Johannessen. I'm a Senior VP Global Operations with Parker Wellbore. I have 30 plus years in the oil and gas industry. Half of that with an operator, but also with large OFS players and drilling contractors as well. Petroleum engineering background, Norwegian, and been in the US for the last 10, 11 years. Our company, that some know as Parker Drilling, more familiar with that, has been in the geothermal business for 4 decades plus, many places around the world, mostly in Indonesia. And we are more than a drilling contractor. We have services that are working on current geothermal projects around the world today. So very happy to be take part in this panel.
Thank you. Fred, go ahead.
Thank you, Sarah. My name is Fred Dupriest. I retired as the chief drilling engineer for ExxonMobil about 10 years ago, and spent the last 10 years with ExxonMobil developing what we call physics-based limiter redesign workflows for changing drilling performance. After retiring 10 years ago, I became a professor of practices at Texas A&M, and I've been teaching for some years and working with industry to implement those same practices in programmatic initiatives across the industry. And it's a real pleasure to be here. Probably the reason I'm on the panel is that most recently I've worked with the Forge program and some of the large drilling gains we achieved there. And that is primarily the involvement I've had with the drilling industry.
Thanks very much. And last but not least, Fabio.
Thank you, Sarah. And yes, my name is Fabio. Have roughly 20 years experience in oil and gas. Working the past 2+ years for Welltec, which is the service company that provides solutions, services, and products for oil and gas, and now, of course, geothermal, and also some carbon storage applications. And my previous experience was in an operator, roughly 18 years in an operator in Brazil. I'm Brazilian, living in Denmark for 2.5 years roughly. And my beginning of my career was in R&D center, so developing technologies and working with innovation projects, and then moved to operations. And most of this period, always working with completions and integration, of course, with reservoir and drilling and flow assurance and all this integration that we have usually in oil and gas, trying to, put all together and help and support the way we can in the geothermal applications as well. And very excited to be here. My second year here is in Pivot, so very, very good. Let's do it.
Excellent. And thank you to the Europeans for joining despite the late hour. For us Texans, it's just the afternoon. So thanks. Such incredible experience. I expect that it will be a great discussion today. Thank you all for providing intros. Just for a little bit of background, geothermal energy costs have remained high over time. There are a number of reasons for this, but a large factor has historically been high well costs due to poor planning coupled with poor drilling success rates. As you all know, we live in a day and age where dry hole risk, OROPs, these things are things of the past for the oil and gas industry, but they are still things that we in the geothermal energy industry struggle with on a daily basis. I want to make sure we're all starting from the same place. So I'd first like to ask you all why, in your minds, has well-designed optimization been so essential for the oil and gas industry? And why do you think it has been deprioritized in the geothermal energy industry to date? Feel free to go ahead and jump in. I will no longer call your names.
If I may, Sarah, Brage here. Especially in Indonesia, Far East, Southeast Asia, I think the norm there has been that the overall owner, the equivalent to an E&P operator, are maybe larger industrial conglomerates or large size companies, and at times might have seen the well construction portion of it as a procurement task, and so the bigger part of the project to generate the energy and what goes into the surface equipment, then turning around and then going through procurement or supply chain, because that wasn't the strength of those industrial companies, led to driving the cost so far down that became second, third, fourth priority compared to some of the larger industrial elements of production of the energy there. We see a lot of old rigs, a lot of old technology still in many places of the world. And another part could be that the benefit of US land, lower 48, the largest field lab in the world, it's not that many places you see that, that you have lots of operator, lots of service company, lots of trial and error, lots of copy and paste and learning from it. That's a fantastic field lab in my view, and you don't see that so many other places.
I would add something in terms of the general structure of most of the geothermal startups that we've been working with. Is heavily based on geology and the geosciences side of things, and right so, because that's the biggest risk when it comes to geothermal wells. But there's maybe less an understanding of the actual physical process of drilling, and maybe that's has to be brought more to the forefront with experience from oil and gas to really dial in on the physics and improve performance.
I think over my career, I think I've seen interest in performance kind of cycle with the price of oil, and also vary quite a bit with the nature and size of the program that you're talking about. Going back to the 70s when I began, when oil was low, performance goes up dramatically. And when oil is high, we get lots of new technology, but performance improve. And it's a little bit of an odd relationship. When you get money to pay for technology, you don't necessarily stress performance because you're not driven. Just from a business model standpoint, you're not driven to change how you work. And performance comes from changing how people work. You don't do that, then you're not going to get a different ROP, a different well productivity. Some days you've got to change something. So I think some of it is really a psychological dynamic to some degree. Geothermals are a little bit, they're discontinuous programs right now. Pick up a rig, drop it. They're low margin. Most are low margin right now, especially where you're trying to extend it and trying to go with it. And it's a little hard to, without a discontinuous program. That's the other dynamic that you face from what I see in geothermals. It's hard to create knowledge, how to do things. As Brage was saying, big programs can do that. Discontinuance struggle with empirical experience-based practices being the approach. Physics-based, understanding every foot you drill starts to make more sense, which is a much more difficult thing to do.
Fabio, do you have something to add?
Yeah, I'll add something. It's very good. I agree with a lot of the things that were said here. What I would add also is that what I can see is that first thing is that this is the $1 million question, right? What can we do to help optimize well design for geothermal, and why we are not speeding up those things? So it's very good challenge. I think it was what I can imagine, and also comparing experiences for oil and gas and geothermal, is that usually in the past, and that it's known that there are also the amount of projects and money invested in oil and gas is much bigger. So usually when you have a big amount of money, you try to save any kind of penny, because 1, 2, 3, 5% in a big amount of money, it's a lot. And sometimes when the budget for a geothermal project is quite low, the first thing you try to do is just derailing things and kind of simplifying the way you do things, sometimes neglecting maybe something that is relevant and it's important, but you have to prioritize, and the resources are very, very limited most of the time. So I think this is one of the drives, right? So also we know that of course, there are a combination of many different aspects. The other one that I think is quite big is that there is no kind of international standard or something that everybody follows the same kind of rules, or more or less the same kind of rules. And especially in legislation and taxation, everything is decentralized. Even inside countries, you have different laws. So there's a lot of energy, time investment, people that needs to work in all those paper kind of things, taxation, legislation, politics, improving projects. And at the end, maybe there's not enough effort or not enough resources to invest in well design, well construction, well engineering at the end. So I think it's a combination. We need to try to, I think there's a lot of room to optimize well design in geothermal. It's just how I see. But it needs to be in the early stages. We need to start talking about well design, well selection in the beginning of the projects of geothermal to support and enable more projects by reducing costs, optimizing resources and everything.
Absolutely. Man, so when asked why well-designed optimization has been deprioritized, we come up with well construction as procurement, no basin activity for shared learnings, less understanding of physical process of drilling, interest in performance fluctuates with price of oil, which I have seen, people, projects, lack of money, discontinuous programs, no international standards. This is a lot of issues that we're going to have to overcome. So I would love to know from each of you, what are some specific technologies and approaches you or your company are working on that are going to improve some of these outcomes and address some of these issues over the next decade? Let's go in opposite order. I'm going to start with you, Fabio.
Okay, good. So my background is I worked with an operator for very long, and now I'm working on the other side, like for a service company, trying to provide services and new solutions. And it's a very good and nice experience because it's a short time. We can deliver things faster. Usually operators are much bigger structures, so things move a little bit slower, and it's very nice. We have this agility to deliver innovation quite quick, and this is very good. So in terms of how and what kind of stuff we're doing is that basically we provide new technologies. I work for Welltec. Welltec has some open hole packers that are benchmark in the industry. So they are most reliable and then robust kind of packer for open hole isolation. And we know that from the oil and gas industry, we know how selectivity and zonal isolation and multiple zones in a well can optimize and reduce costs in well construction. In the past, the oil and gas has saved a lot of money by reducing number of wells, by improving or increasing the number of zones in a well, for example. So this kind of capability or ability can be beneficial for geothermal wells as well. And when you are able to provide robust, reliable zonal isolation in open hole, you also reduce cementing costs, and also maybe you can reduce the size of the well you're drilling. So you optimize the whole well construction by reducing the previous phases of the previous casings. So again, instead of drilling a larger wellbore, running casing, cementing, maybe you can put your equipment and isolate in an open hole. So reducing a lot of costs and optimizing. This is pretty much what we are doing. And in terms of new technology, we are involved in a lot of projects, kind of spread out in the world. Let's try to focus in the U.S. We have a lot of projects with DOE, Department of Energy in the U.S. and Forge as well. Also some technologies with material. We are developing a new packer that is full metal that isolates the annulus without any kind of elastomer. We know that especially for EGS markets with high temperature, elastomers doesn't live a lot of time with these environments, also corrosion. And on the maintenance side, we have a lot of solutions, again, for milling solutions, for scaling. That's very strong. Our millers and our tractors, they are, again, one of the top in the market. So this is how we are trying to collaborate and cooperate and also connect with a lot of other service companies, other operators to deliver more solutions, identify, bottlenecks and challenges, and try to deliver, as I said in the beginning, quick solutions, quick innovations.
Excellent. So that is a lot of interesting new technology. I know others will speak about technology. Fred, I think you have a little bit of a different flavor of answer that speaks a little bit more to people and process. What have you learned from Forge?
Well, what everyone may not be familiar with Forge. It's a U.S. government DOE funded full field development where you go out and do things to prove new technology. And in our case, we brought a process and workflow, which really I think kind of got formulated at ExxonMobil, but it's spread across the petroleum industry, which says, let's move toward physically understanding everything we do. And then here's what are the physics, and we call it being physics-based. For example, and if I do that with everything that's limiting my performance, and then it's not limiting anymore, and then now what limits me on that? What are the physics? What can the driller see to decide? What can the engineer redesign? Now what limits me? And you just continue to progress your weight on bit, your ROP, and your RPM. That's the granular performance that really matters, is how fast are you drilling your wells? And that's about weight on bit and RPM. Trip time, yeah, but you can have your cake and eat it too, and that's how it works out. So by being physics-based and promoting this programmatic approach of, well, how do you be physics-based? Where do you get the physics? Where do you get the practices? That's the pivot. That's the pivot that needs to happen in practices, and not necessarily technology. I got Schlumberger. I got the same bit company. I got everybody having locations the same as in the oil field. And yet I'm not operating the same as in the oil field. And that's about knowledge transfer, creating it, and how it's used. I don't mean experience type knowledge. I mean physically understanding. The geothermal industry lags in the degree to which it has taught people how things work. I'm not bragging on the oil field, because what you have are leaders there that other people copy for the most part, but it's a pretty large number of leaders who are teaching a lot of physical processes and how they work. If I know that, then it doesn't make sense to me to keep working the way I am, and it makes sense to me to work some way different, then I'm willing to do it. The willing to go do it is what separates one rig, forget geothermal petroleum, one rig from another rig, from one management group, from one group of engineers, the willingness to go do it. How I get willing is for me to understand physically how something works, so that what I was doing doesn't make sense anymore, and some other thing really does. So that's what I'm engaged in. And, we knocked 80% of the rotating hours off of drilling 5,000 feet of granite. We've been drilling 15 feet an hour and going and budgeting it, selling management and saying, that's great. You come in at budget, you're doing great. Well, then you go out and drill over 100 feet an hour, like clockwork, okay? If you keep redesigning the physically, what limits you, and you physically understand it. So I think the geothermal industry needs to figure out how to pilot the physical knowledge, how to deliver it and create it in a rig team, and then adopt some of the processes for how you drill and use that have been developed workflow-wise in the petroleum industry, not technology. We all have the same technology. If you want to work differently, then you have to, actually it has to make sense to people, and then you have to have processes that support and enable them to go out and do different work, different ways.
Yeah, it's a really interesting answer. And I think that the way the Forge has really paved the way to act as a leader on physics-based decision-making has been a really, really big step forward for the industry as a whole. And I know that we are very consistently grateful that the Department of Energy is funding that project, and that they have so collaboratively shared their results, because it's been pretty awe-inspiring to watch those results come across. Brage and Scott, I want to give you all time to discuss what you and your companies are working on as well.
Okay, so reverse order, I'll go first. So really the crux of what our company was based upon was physics-based modeling of the drilling process. So torque drag and buckling, vibrations, drilling dysfunctions. I mean, Fred could talk to us for days about that if he wanted to, but ultimately what we're looking at now with the whole digital revolution in oil and gas is really moving towards real time, taking the data streams that we receive from the rig, coupling that with our physics-based models, and coming up with real-time solutions. So looking at the mechanical specific energy in real time, trying to find the sweet spot for drilling optimization. Same for tripping out a hole, trying to identify whether we've got any hole cleaning problems or anything in real time. We offer that as a service to companies in oil and gas and in the geothermal industry. And just to touch upon another thing that Fred mentioned about the discontinuity between projects and geothermal, we want to act as a sort of knowledge centre for those geothermal operators, where our learnings from one geothermal operation can come into another. And although they're drilled in different spaces, different geological formations, etc., there's a lot of transferable knowledge that we can bring. On top of that, we also have a lot of well construction experience from oil and gas. And again, it's not bringing new technologies, but maybe bringing more advanced methods to casing design and well construction to optimize the design of the wells from the very beginning, and really question what are the goals of the well, and bringing that right down to an optimized de-risked design, and couple that with the drilling optimization, and you try and de-risk the cost of a project as much as possible.
Go ahead, Brage.
Thank you, Sarah. Follow on some of what Fred and Scott said too. I think if plenty of companies are working on the downhole and improving ROP, but I think in the end, what we're aiming for is to get to the lower cost. It's reduced time and consistent delivery of those wells, so it becomes easier from a planning and budgeting and supply chain perspective. If everyone involved in these projects are working consistently and delivering consistently without train wrecks and with optimum planning. So Parker Wellbore, we 84-year history, and has been known and has a reputation of being willing to both go places where the others might not be willing to go, but also be part of rig designs for optimized for the application, whether it's world record ERD wells. It's the first heli rig that was built ever, and many of those examples. And just recently, we were awarded the engineering and technology consultancy for a new build well for an operator, a geothermal operator in Indonesia that is looking at building a new one fit for purpose for geothermal wells. So we're really looking forward to be part of that. The other part of Parker Wellbore is casing running services, whipstock, drilling BHAs outside of the jewelry that goes in. And to that point, I think it's extremely important with that consistent delivery. So be as efficient as possible over and over again. And we have proven that, especially with our tubular running services, of being upper quartile in pretty much every environment we work in, whether it's the Middle East, it's in basins in US and North America. And where we also have our own proprietary technology and products that we are continuing to get new generation and further advance those, all as part of that consistent, high efficiency well construction delivery.
Wonderful. I feel like one of the questions that's been running through my head is, there's this really interesting graph that Geothermex put together of historic drilling success rates for geothermal energy. And what it showed, that even in deep basin time, when you are doing a continuous drilling program, the success rate of drilling in the geothermal energy industry is still sort of only 2 out of 3 wells. That's a pretty binary outcome. 1 out of 3 wells is dry hole, meaning completely unsuccessful, not producing at all. What you all are talking about is better real-time monitoring for optimization. You're talking about more physics-based decision-making. You're talking about zonal isolation, which so far has not been something that has been applied at all in the oil or in the geothermal energy industry. What do you all think is the impact that can happen. And you can frame this however you think. I think in LCOE. So I'm typically thinking about what is the impact of reductions in drilling cost on my LCOE. But what do you think is possible impact of the implementation of some of the technologies that you all have been discussing today? Fred, you look like you want to answer.
In 3 minutes?
Go for it.
That's what I'm sitting here thinking about. And the audience may not know we're trying to do this in 3 minutes each. So I'll share a little epiphany with you. And Brage has made the point about consistency and predictability. That's management saying, I'm going to give you X amount of money. I want this return. So I need you to be reliably spend what you said you were going to spend. But that didn't improve the performance. And that's part of our issue, is that it's a management by objective philosophy. It doesn't improve performance. It makes me resistant to changing how I work, because I know I promised you what I already know I can do. So I think this is where you really have to stress limiter redesign. You increase ROP by weight on bid and RPM, or by addressing a dysfunction that is preventing you from doing that. Turns out that all the dysfunctions that cause our trouble time are the same ones that are limiting ROP. And if you are relentlessly redesigning what limits you from more weight on bid and RPM, you are getting rid of trouble time. Now, when we started kind of a limiter redesign philosophy in all of our drill times, we had 17 worldwide drill teams in ExxonMobil, and we were drilling mostly extended reach world-class wells worldwide. And we had about a 20% trouble time, which is leading the industry in that class of well. In 4 years, we reduced it to 12%. No one's ever touched 12% in that class of well before, and we had double footage per day. So what happens is very much like people say, well, what happens is that if I have trouble time, I've got drag and I'm tripping and I stick pipe in a tight spot and I ream. Well, that's on your target list for things that limit you. It's slowing down progress per day. So you say, well, what are the physics of that? Well, it's spiral hole. No, it's not any sand there. It's not filter cake. Here's the physics. Physically, it's this. Run longer gauge bit, put more weight on bit, don't let the bit whirl, reduce the motor bend to only what you need. These are specifics. If you eliminate that tight hole, you're drilling a lot faster, because the same whirl mitigation makes your bit go faster. And so it just works this way. And it's a kind of an epiphany that we didn't realize this was happening until after 4 years, we sat down and looked at our trouble time and go, holy cow, we have one stuck pipe event in the world in a $5 billion drilling program in that year. Why is this? Well, because it works that way. So I'm going to come back and I'm going to argue that if we want reliable, predictable performance, we don't need optimization. Optimization is where you push something until the pain exceeds the gain. And then you identify that point stochastically, whatever, and you sit there. We want limiter redesign. That's a limitation. Redesign it so it doesn't limit you anymore. And then something else until it doesn't limit you. It suddenly what you'll find is you're surrounded by a huge safe space. You don't have stick slip, you don't have whirl, you don't have lost returns, you don't, all these things. Whirl is what wears out all our motors and all our stabilizers. You don't have those things anymore, because you're pursuing what limits you relentlessly and with an attitude. And that has to come from the operator, and that has to come from management, with a whole lot of changes in how we work all the time.
Absolutely. Who would like to go next?
If I can follow up on that, Sarah, I think Fred touched upon it earlier too. I think in order to get there, you need continuity, not only in continuous operations and well programs, but I think you need continuity in your partners together with the operator, whether it's geothermal or oil and gas, because with trial and error, right? And that is how we learn fast, and don't repeat, learn from those errors and or mistakes, so you don't repeat those, and then you move on to the next. But that means you need to be that partner, chosen partner for a period of time so that you can all learn together as a system, right? Again, I bragged about the US Land Lower 48, the largest field lab in the world. The problem there is it's not partnership. You're not there for term. So you need to, so it drives, to Fred's point, it drives performance over and over and over again, but it might not be the best place for trying new things and pushing the boundaries that Fred was talking about. For that, you need partnership, and you need to be willing to trial and error, learn from testing out things.
Brage, how has Parker Wellbore's approach to partnering with geothermal operators changed in the time that you have been there? Have you seen a substantial change in willingness to partner with geothermal companies in the last couple of years?
Well, I've only had 2 years with Parker Wellbore. I think, but what I've seen, and also from prior companies I work with, that was pretty much sitting right in the middle of oil and gas, and that's all they looked at. That coincidence or not, the pandemic, the shock oil prices we had for a short period of time, forced and accelerated, I think, for whether you're an operator or you're a service company, accelerated this view of looking at the energy transition space. And whether that's geothermal, CCUS, and other things, going and looking at who you can partner with, but also look at yourself. What are we doing that we can take our learnings from the oil and gas space and implement those within the geothermal space and be part of the energy transition? So for Parker Wellbore, last year we issued a new strategy and a vision of becoming a partner within that energy transition space. And a lot of that, again, based on our 40 plus years within geothermal industry in many places around the world, and the learnings we had from that. And earlier this year, then we established our own energy transition business unit within Parker Wellbore. And so those are the things that's happened only in the last year or so. And it's fascinating to see and also be part of a company that wants to be and want to adopt the change, wants to be part of it and drive that change with that strong foundation of all the learnings we've had participating in geothermal projects for 40 plus years.
And Scott, I want to ask you a similar question, and you're also welcome to respond to my question about impact, but I know that H&P has made some real moves to partner with geothermal companies, recognizing the value over the last couple of years, and I would love for you to speak a little bit about that as well, especially since lots of our audience questions are coming in, and many of them are asking about geothermal and oil and gas partnerships.
Yeah, so so I joined in just last October, so it's one of the main reasons I decided to join Drillscan, Helmerich and Payne was the involvement that we do have in the geothermal space, mainly because what I can see with my skill set and the experience we have in Drillscan is we can add a lot of value to that process of drilling the geothermal wells. So in the past couple of years, similar to what Brage has said, there's been a geothermal segment lead set up in the US where Helmerich and Payne have made investments into a certain amount of different operators in the US and are looking at that internationally as well. And we work in partnership with those companies to provide well construction services, drilling optimization, whatever is needed to make those projects a success. And sort of building on top of what Fred and Brage have said is really bringing that drilling, because like Fred makes a real point about it really has to be, the performance has to be driven by the operator. My experience that I've seen so far in geothermal is most of the geothermal companies don't have a drill department per se. So some do, some don't. So being able to provide that to an operator brings a lot of value in trying to drive forward these reusing the word limit or redesign, or these processes that we're looking to improve the drilling performance, improve the well construction process as well. That's really where we're getting involved in working in those partnerships. So it's a lot of trust. It's different in oil and gas where you're a service provider, and that's sometimes the limit of the relationship. But Helmerich and Payne has a real good trust method, trust ethos inside the company and with oil and gas partners, and we're pivoting that, the favorite word, into geothermal as well.
I know we personally have appreciated that commitment. Fabio, I'm going to pick on you really quickly because of your commentary around zonal isolation. One of our audience members has asked the question, what specific technologies have not yet been transferred into geothermal from oil and gas that the panel feels would have the highest impact if applied? And since you spoke about zonal isolation, which is new for geothermal, I'm going to pass that question to you.
Yeah, that's great. And also, I think it is totally linked with the answers that our panelists were just saying. So there are a lot of effort that we can put, for example, to optimize performance, as you said. But when I think of well-designed optimization, and when I mentioned earlier that we should or maybe try to bring the discussion of well-designed selection, well-designed studies to the early stages of the project, is because maybe we can, of course, there's always some room to optimize operations, right? We can always look for new technologies to increase ROP and RPMs and efficiency and thermal efficiency and so make, create new bits that will last more, so you reduce the number of runs. But at the end of the day, more opportunities to really impact with bigger savings when we change in the planning phase, and this is known in all industries basically. So, for example, challenging the design that is selected at first place, maybe would be a chance, for example, why we are copying and pasting some 12.25 wells and doing all over again. And then instead of doing this, we could, in the beginning of the project, think, do we really need it? Because somebody will challenge you and say, yeah, we need the biggest hole as possible because we need a lot of flow rate. But why we need a lot of flow rate? Because we have a lot of uncertainties. We may need to drill further or not. We may find some thief zones, some code zones. So then you start to dig into it and try to understand the needs. And then you say, okay, so you need more flow rate because you have uncertainty. You need to compensate maybe some code zone that you may find. So why not maybe drill a slimmer well that will be faster, but you can provide and install some instead of just a liner all the way through. And with some valves controlling, you could, for example, close a thief zone, close a code zone, increase the efficiency of the well, and you would be drilling a thinner well, a slimmer well, maybe just because you reduced the reservoir or the rock part, the lower part of the well with a slimmer size, maybe you can save even a stage in the previous phases. So the number of savings and the impact of savings could be much bigger. So in terms of how can we impact, I think our biggest impact would be if we really bring the well discussion to the early stages of the project, because this is where you can make decisions best, right? Because at the end of the process, when people just call a contractor and say, hey, I need to drill a well here, then you say, okay, well, what kind of well? Then you say, oh, we need a 12.25. Then we're gonna run on 7 5/8 or 10 3/4. And then you said, okay, but what if we do this, we change this equipment? Maybe you're gonna drill, maybe the well construction could be expensive more or could not, it depends. But the efficiency of the well and the outcome would be much greater. So, and then you talk to the client and they say, yeah, but this is the budget we have now because it was approved 1 year ago or so. So then actions are limited. So this is how I think we should try to approach and maybe foster the discussion. So bringing the well-designed solution discussion to the early stages. I think that answers also the questions a little bit in terms of how could we improve or what kind of technology could we install and start to develop more. I think zone isolation is a good one to say.
Yeah, these are incredibly difficult issues in a new, it's an old, as we all agree, industry, but it's new in the vision that we all have for it today. And I think we've all been sort of spoiled by the way that, we've gotten to think about continuous drilling and tweaking our designs over time in the shale industry, because we've benefited from such high volume over the last 2 decades. I would love for anyone to respond to Fabio that would like to. I saw some nodding in the group.
Yeah, I'd quite like to add to that. A lot of what I've seen as well, the sort of internal process that I was used to following, and I'm sure some other people that have worked in operators, is geoscience is the client, and the drilling department, you almost have you have a contract between the two of you as a statement of requirements. That sort of process has to sort of happen between geothermal companies that don't have a drilling department and companies like ourselves or Parker Wellbore or whoever, to ensure we are involved at the very beginning of the well design process. Because like Fabio was mentioning, if we step in at a later point and the project manager, whatever, has a very set idea of what they've been told they need without actually questioning why, you're kind of limited in how much you can improve the well design and, like Fabio said, the outcome of that well. So I think just having that experience from oil and gas and having that almost being the pain in the neck of the geoscience department, we almost have to play that role in geothermal as well to make sure wells are delivered and achieve exactly what you want them to achieve for the minimum cost, minimum risk, etc. So Fabio made a great point there.
I think both Fabio and what you're saying now, Scott, too. I mean, a great example would be if you go deep water wells where because of long lead item and planning around that, you might have to order and design the Christmas tree wellhead prior to deciding your completion outcome. But because of that decision making around the production Christmas tree, you're limiting your completion. So if all parties were brought in at an early stage to discuss these limiting factors, then the outcome could be changed. And to Fabio's point, maybe, I mean, if you can design your way out of a whole section, there are tremendous savings in that, right? And what Sarah mentioned, 1 out of 3 wells is a dry well in geothermal with a possible slimmer well design, and you do a pilot hole and to see what's down there and pull back, you could save a lot of money and may possibly whole sections.
I think I would actually say I think Fabio's really hit something really critical, which is zone isolation. It's been critical. Where's your heat coming from? How do you control your water? And now we're starting to add multiple fracture ideas, and it's if we can't do zone isolation, we can't do most new geothermal ideas. And it's about elastomer temperatures and technology in this case. So I'm on the technology bandwagon here. But at the same time, I would say that the #1 problem we've actually had with the elastomer elements is getting torn up on the way to the bottom of the hole. In our environment, in the heat, and granite. Now, this is a forge experience, but the rugosity that we have is tearing the pecker elements up. And that's why we're having to run really big boreholes, and we want fiber optics and other stuff down there too. But we need smooth holes, and drillers need to drill smooth holes. And guess what? The way you drill a smooth hole is really fast. If you drill slow, you're guaranteed to have a rugose, spiral, difficult hole to get anything down at all. You run a longer gauge bit, you manage whirl, you manage whirl, you manage whirl, because where that's coming from is side cutting of the bit, and the side cutting force is coming from the bit whirling. So we understand, if you understand the physics of all of that, then you can drill smooth holes. And if you don't understand the physics of where your not smooth hole and all your drag is coming from, you can't and you won't. And so I'm kind of coming back to my same thing is we don't need technology transfer. We need a physics-based knowledge transfer. I don't need experience transfer. I need someone to physically understand how bad hole is created, and we cut every inch of that ourselves. Bent motors, we got to get rid of them. Okay, we need rotary steerables and long gauge bits. That's essential. But we need to run. You know, we got up to 70,000 pounds on our 10 5/8 bits in the granite, and there's no bit problem with that. So the things that limit you, and the 7,500 engages the cutters, keeps the bit from whirling, drills to smooth the hole. So there are many things that contribute if you understand the physics of how these things are being created that I can go work on. Number one, I sit the whole team down and I say, higher weight on bit doesn't drill the bit faster, wear the bit faster. If I can't convince you of that, we're not going anywhere because it intuitively doesn't make sense, but it's absolutely true. So you just keep piling up physics and physical understanding. And if you understand things physically, you will change your practices. If you don't, and operators won't invest in teaching people stuff or building their own pile of knowledge, physical knowledge, it's deterministic, then you're going to struggle with that. We need smooth holes. And I agree with Fabio, zone isolation is critical. I don't think you're ever going to get it if we don't do something about the rugosity of our holes in hard rock.
Fred, thank you for that. I'm going to give Scott, Brage, and Fabio each 1 minute for your closing remarks as well, and then we will wrap it up.
Okay, so thank you very much for me being part of the panel. It's been a pleasure meeting Brage, Fred, and Fabio, and yourself. I think the main thing for me that I've taken away is we have to be involved early in the process, and it's not just talking on what Fred said, it's not an experience transfer, it's a physics-based knowledge transfer, and really understanding what we need to achieve in the well and have an opportunity to do that in partnership. And I hope that was a minute.
Perfect. Go ahead, Brage.
All right. Yeah. Thank you, Jamie and Sarah, and for inviting us to this panel discussion. Great to listen to, and the other panelists, Scott, Fabio, and Fred. For Parker Wellbore's side, we with our new energy transition vision and strategy, and couple that with our long history within geothermal drilling, we very much want to be part of this, willing to be a partner not only within rig design, but of course also within the well construction designs and the elements there. And so great input from all the panelists, and thank you very much for letting me take part.
Yeah, so again, just a big thank you. We were talking about what kind of impactful actions, and this is one of it, right? Pivot is really impactful in geothermal and pushing geothermal. So it's a great pleasure to be here for the second year. And thank you, Sarah, for brilliantly moderating the session. Fred, Scott, Brage, for sharing this session was very good. And thank you for people that are sending questions to us that makes us, think a little bit further. So great. And thank you, Jamie, again, for inviting. That was great.
And thank you all for being here and for taking such time to be thoughtful and deliver thoughtful answers. I have really enjoyed meeting all of you. I spend a lot of time in my day-to-day job trying to convince stakeholders why now is different in the history of geothermal energy. And I think panels like this, talking about all of this interesting technology that remind me of my oil field days, is what provides me with a lot of optimism that now really is different. And we are going to make huge amounts of change and work to address climate change together. And so thank you all for being here. I very much enjoyed it, and good luck to the rest of 2022.
Thank you, Sarah.
Thank you.
Thank you.